Hello, Algebra 1 students, and welcome to Lesson 1.5 on solving inequalities in one variable. So far we've been doing a lot of equations, right? Getting x by itself, finding what x equals. Well, now we're going to do what are called inequalities. Same idea. We're still trying to get x by itself, but there is one big difference, aside from the symbols, to doing this. Okay, and I know you have some prior knowledge of inequalities. Again, my kids in second, third grade are using the greater than, less than symbol, so I know what you know what those are, so don't pretend like you don't. Okay? All right, so let's solve this inequality. So it says solve -4, parentheses, 3x minus 1 plus 6x is greater than or equal to 16, and graph the solution. So this symbol right here is called a greater than or equal to symbol. And I'm going to do it right over here. So this is pronounced greater than, or equal to. So that line underneath is the equal to part. So again, remember, right, if the mouth is open up to the left, so it's open, that means the left thing is bigger than the right thing because the mouth is hungry. Wants the bigger thing. So we are going to solve this the exact same way you solve an equation. So the first thing is we're going to distribute. I see parentheses, so we're going to distribute this -4 into the parentheses. So -4 times 3x is -12x. -4 times -1 is +4. Bring down the plus 6x. Bring down the greater than or equal to. Bring down the 16. Okay. Now again, if you are someone who prefers the line down the symbol, I will put that line down the symbol like this. Okay, so now on the left-hand side, I see like terms. I see a -12x and a +6x. Combine them as they are to get -6x. Bring down your +4. Bring down your 16. Now I am going to continue to write the greater than or equal to symbol. And I know it's kind of tough because that red line is red, but there it is. And now it's a two-step, right? Next thing is addition or subtraction. I see this +4. We need to subtract it because it's positive on both sides. So the -6x comes down. Those 4's cancel. We bring down the greater than or equal to symbol. And then 16 minus 4 is 12. And now I need us to, I'm going to change colors. I need us to make a big deal about this next thing. I'm going to put it in green because green's my favorite color. Big deal. So the next step we're going to do is a division. So the -6 is in front of the x, so we're going to divide both sides by -6. And I will extend this. And here is the issue, right? If you think about an equation with an equal sign, equations you can flip them around, no big deal, right? X equals 6, 6 equals x, it doesn't matter. But with inequalities, there's direction. That is a greater than symbol, right? When you divide by a negative, that negative is going to change this -6 into a positive number. So they cancel, you get x. That negative is going to change that +12 into a negative number. So it changes the sign of the terms. Well, the inequality has direction. It is not, what do I call it? It cannot avoid the effect of a negative. It has to change direction as well. This greater than symbol must reverse itself and become a less than or equal to. So the final answer here would be x is less than or equal to -2. We're going to make a huge note right here. Again, I don't know how big you can write this star, right? The rule is, and this is the one big difference between inequalities and equations, if you multiply or divide by a negative number, reverse the inequality symbol. Reverse the inequality symbol. Reverse the inequality symbol. All right? So make sure you do that. So now this is pronounced x is less than or equal to -2. So now we want to graph this, right? And I'll change colors again. I'll go to blue. And I'll put a little circle around the word graph up here. So when we graph, we are using a number line. So here's my number line, and there's many different ways to do this. Different teachers have different methods. I'm going to do it this way, okay? So I'm just going to put the -2 smack dab in the middle. I don't care about 0. I don't care about -2. Now, because this is equal to, because of the equal to, you are going to put a solid dot above the -2. So I use a solid dot because it is equal to. If it's not equal to, you put an open circle. That means that -2 is part of the solution set. And now, less than means left. So I'm going to take my dot and I'm going to draw an arrow to the left. And again, I went to the left because this is less than. And this is what my graph looks like. It's a number line showing that x can be -2 or anything less than -2. So -3, -4, -5. So when you solve an inequality, it's not one solution, it's a solution set. All of the numbers less than or equal to -2. Okay, next. Another example here. So it says, we're going to solve the inequality. All right, so this says 3.5x plus 19 is greater than 1.5x minus 7. So notice there's not the equal to, right? Just greater than. Then we're going to graph the solution. So again, I'll draw my line down the inequality because there's no parentheses, right? No distribution. I'm going to bring my 1.5x over to the left by subtracting 1.5x on both sides. This is nice because the decimal goes away and you get 2. So 2x. Bring down the 19. Again, bring down the greater than. Bring down the -7. I'm going to now do addition or subtraction. Let's move the 19 to the right by subtracting 19 on both sides. So we get 2x, the 19's cancel, is greater than -26. And now the number in front of x is a 2, so we're going to divide both sides by 2. Right? And again, I'm going to put a star here again because I did divide, right? Maybe I'll change colors to green again. But here's the difference. That's not a very dark green. There we go, dark green. The difference here is that 2 is positive. That is not going to change the sign of this 2, so we still have a positive. It is not going to change the sign of a -26, so it's still going to be a -13. So it's not going to change the inequality. So this greater than stays greater than. It doesn't change. So we did not divide by a negative. So we did not change the inequality symbol. So x is greater than -13 is the solution here. Okay? So again, I did not change the inequality symbol because I did not divide by a negative. And now to graph this, I'm going to draw my number line. Again, I'll put -13 right smack dab in the middle. Now we don't have an equal to, so it's going to be an open circle. And again, this is because it's not equal to. Right? There's no dash underneath that inequality symbol. And because it says greater than, now I'm going to the right. So I'm going to the right because it is a greater than symbol. And there we go. And that's our graph of the inequality solution set. So again, in this problem, you cannot be -13. You can be anything bigger than -13, but you cannot be -13. All right, last but not least, a word problem here. All right, so again, in reality, a lot of word problems should be inequalities, not equations, but here we go. It says, Derek wants to order some roses online. For what number of roses is it less expensive to order from florist A? All right, let's just stick with that. The other side's going to be, we're going to ignore that because, again, whatever's less than florist A, the other side will be for florist B. So just ignore that. So we want to figure out how many roses for it to be less expensive to order from florist A than from florist B. So we want to let A be less than B. That is our setup here. This is our inequality. Okay. Now, it says, for what number of roses? This is your variable. You know that x is going to be the number of roses. So down here, Notice it says 475 per blue rose and 515 per red rose. Those numbers get the X next to them. All right? Okay, so I'm going to do it right here, and I might have to go to the other side. I apologize for the lack of space. So it looks like we're going to take florist A, which is 475 per rose, X, add the $40 delivery fee. We want that to be less than the $5.15 per rose of red plus the $25 delivery fee. So there's our inequality. Okay. I'm going to solve this in green. So I don't have any distribution. Here's the line down inequality. I'm going to move. So there's choice here, right? So sometimes people say, let's move everything the variable-wise to the left in terms of inequalities, because you do want to be variable first. I'll make that a note right here. Right? We need to be variable first. So if you think about when you solve equations, you could have x equals 6 or 6 equals x. It doesn't matter. But for inequalities, so that we can trust the inequality symbol, we want the x first. Now, to solve it similarly to what I've been doing, I'm going to move the 4.75 x to the right because that keeps it positive. You might choose to move the 5.15 x to the left. You can do that too, but it's going to make your x term negative, and you have to remember that rule with inequalities. So again, math, it's so hard because there's multiple ways to do it, but that makes math great. So we're going to subtract 475x from both sides. Okay, so they cancel here. So I get 40 on the left. The less than stays less than. This becomes 0.4x plus 25. Okay, add or subtract. I'm going to subtract the 25. Again, I move the variables to the right, so I'm moving the numbers to the left. 45 minus 25 is 15. 15 is less than 0.4x. And now I'm going to divide both sides by the 0.4. And I'm going to bring it over here. So 15 divided by 0.4, that's 37.5, you get a decimal, is less than, and the 0.4's cancel, x. So now this is not variable first, because the variable's last. I need to make this variable first. So I need to take this entire inequality and flip it around. So watch what I do. I take the x, and I put it over here. I take the inequality symbol. I need the mouth to continue opening to the x. So it gets flipped around, and 37.5. So this is the inequality symbol that we need for this. We need to flip it around. So x is greater than 37.5. That's a 7. Now, to answer this question, right, obviously you cannot buy 37.5 roses. So the answer to this question would be, so for what numbers of roses is A less expensive? I would say 38 or more roses. So again, their second question, what about from florist B? So if 38 or more is when A is less expensive, then the other side of that would be 37 or less, and that would be what B is less expensive. All right, so thanks for watching this video. I hope it all makes sense, and we'll see you in class to do more practice and to get that assignment done. All right, again, thanks for watching, and we'll see you next time.